Hi, I'm Joey. Welcome to our Calculus Legacy project. We're going to talk about the environment, which is something that's often ignored today by our standards, but it's facing a lot of issues. Among them are fracking, global warming caused by the carbon emissions, and a variety of other problems. But we can use mathematics, and especially calculus, to analyze these problems, and then we can see how severe the problem is and work towards a solution.
Not only are there severe damages done to our environment, but plenty of animals are endangered or going extinct because of all the hunting that goes on. By examining these trends in calculus, you can predict which species need the most protection and which species are finally coming back.
So here we have two separate graphs, one of the carbon dioxide concentration leading up to a couple years back, and then here is the graph of the temperature, because as we said earlier, these two are interwoven, so it's nice to display both. You can see the ups and downs seem to match each other, and if you look on the x-axis, this goes back way 800,000 years ago. They use the soil and fossils they found from that time to determine exactly how much carbon was found in the atmosphere, and then you can see, now this is an older graph. If you look at newer ones, we're actually way up here, almost at 400 now. You can find a similar graph, but more accurate and closer in Al Gore's book, In Inconvenient Truth. It's actually pretty much the same thing. So you can see that we're getting up there with carbon, and now because we're all the way up near 400, we're around, I'd say, 370. Then we've surpassed all the previous heightens. And a lot of people will argue, well, you see it goes up and down the past. Yeah, but our impact is grown so much that we're doing such disastrous effect, and the temperature is going to continuously rise unless we do something about it. So what we're going to do is we're going to find the rate of change at 50 years before the present, and then we're actually going to, because it's been a straight line since then, we're going to use that to calculate 50 years from the present. So 50 years ago, we were at about 260 parts per million, and now we're at, I said earlier, I think it was 360, so we're at 370. So we have 370 minus 260 parts per million, so we get 110. So that's our rise on the graph, and then we can divide this by 50, because it's been 50 years, so we can see that that's increasing at a rate of about 2.2 parts per million per year. And then using this, we can calculate how much it'll be in the next 50 years, and because it's 50, we can see the growth will be about the same if it continues at this rate. But the problem is, we're also making this rate increase. So it's not going to be an exact estimate. Chances are it'll be much higher unless we act quickly. So in 50 years, we'll be up at about 480 parts per million of carbon in the atmosphere. And that's just really bad. We don't want to see that. It's going to make our temperature be all the way up here. If you saw our temperature graph, just imagine this curve going up. We're going to be increasing at an increasing rate. So that means that the temperature is going to be unseasonably hot and then unseasonably cool, because we no longer are supposed to call it global climate change. We now refer to it as, or global warming, sorry. We now refer to it as global climate change because we're having colder winters because of the lack of ozone, and then hotter summers because of all the carbon out there that's trapping all the heat inside. So our planet is getting a lot hotter, and it's becoming very troublesome, and we're basically killing ourselves unless we do something about this quickly. And like I said, this number is only if we were to stay at the same rate. Unfortunately, due to population growth and how much energy we're going to need that's going to skyrocket. We could be above 500 parts per million carbon in the atmosphere in 50 years, and we just don't want to see that.
Okay, so here we have a bar graph of the total extinctions over the past 500 years in increments of 100 years. As you can see, it's increasing at an increasing rate. This line is the total amount of extinctions. So if you add these years together, that's what's happening. That's why it's higher than just the bars. And this just shows the total extinctions in that 100 years. However, it looks like in the 2000s we've been doing a really great job, and not that any animals have been dying. However, we're only 14 years into the 2000s, so this isn't very accurate as compared to the other ones where the full 100 years has been completed, and this will probably be increasing much higher by the time we reach 2100. So if you're going to find the average rate of change from the 1800s to the 1900s, you use the total amount of extinctions or deaths from these bar graphs. So for the 1800s it was 120, and for the 1900s it was 500. And now you subtract these, so do 500 minus 120, and then you do it over 100 because it's been a change of 100 years. This is going to give you the rate of extinctions or deaths per year. This will help us predict the amount of extinctions or deaths each year in the 2000s, except for since it's increasing at an increasing rate, that's going to mean there's even more than 3.8. We hope that by solving these calculus problems, you have a better appreciation for your impact on the environment and how the environment changes.
Thanks for watching.